Okay, so today we're talking about mark and sweep. How do you explain mark and sweep? Well, mark and sweep is a garbage collection that says you have a stack with references. Let's say we have two references, x and y, and let's say we have a heap of objects. The objects are, I don't know, let's say we just have these objects and right, each one represents something. Let's say x points to this object, y represents this object. Now I want to declare object C with a pointer to an object here, but I have no space for it. So what do? I'll traverse the stack of my program, and I'll see what x points to, and I'll mark it. What y points to, and I'll mark it. And that's it. Those are the only two objects in my heap with current references in my program. That means everything else is lost. I don't have references to it in my program. It's garbage. Then I traverse my memory. So I traverse the entire heap. And I go and I ask myself, is this object marked? No. Erase it. Is this object marked? Yes. Is this object marked? Yes. Is this object marked? No. Erase it, erase it, erase it. Erase everything that's not marked. Now you have space. Now you can declare new objects. And you can keep going. So you only run the mark and sweep algorithm whenever you run out of space. Okay. In this case, we are doing this with mark and sweep of x1 and y, or we are declaring an object and we're simplifying it. The object we're declaring is an or. This or is between a y and something. That thing is an and of two things, an x and a true. Okay, so this is our object being created, so we'll begin the creation with a heap size of 22. We've already used 2, 2, 1 pointers and stacks, which means that we have a size of 17 left. So we're going to begin with declaring our var expression x and our var expression y and our and expression with true and false, with left and right, and our or expression with left and right. This is used 2, 2, 3, 3, so that's 6 and 4, that's 10, which means you've got 7 left on our heap size. Now, the end expression points to x and true, so the end expression is going to point, its left is x, its right is true. The or expression, its left is the end, and its right is the y. Okay. We then say simplify visitor do it, so we're going to have a simplify visitor. The simplify visitor is going to traverse our expression, our or expression. So again, our expression is or and x, true, y. Now, this requires an understanding from the labs that the simplify visitor works this way. So if you call simplify something, if it's a var expression, it returns that expression. If it's a constant, it returns that constant. If it's a variable expression, if it's a constant, it returns the constant. If it's an or an and, it's going to return, or even a not, it's going to return new objects of those things. What am I saying? I'm saying if I feed var expression, if I feed simplify an x, it's going to return a pointer to that very same x. If I feed it y, it's going to return a pointer to that very same y. If I feed it an and x and y, it's going to return to me an and of simplified x and simplified y. So it's going to return to me a new object. The same thing with or, the same thing with not, but this also depends on your implementation. You could skip this some way, but for our sake, we will assume a naive implementation of simplified that returns new trees and same leaves. So that's the rule of thumb when you talk about simplify. So given this and x true, what do we return? Well, we begin with going on simplify or, calls a simplify y and a simplify on and. Let's go in order. So we call simplify an or. So it says, oh, okay, so left child, return simplify left child, and, which is going to return simplify x. That simplify x is, how do you simplify x? You can't. So you return a reference pointer to that very same x. Then you say, okay, what about true? How do you simplify true? Well, you can't. So you return a reference pointer to that very same true. Then you say, okay, well, simplify and, what do I return? Well, I return a new and with the simplified left child and a simplified right child. And that's my new and expression. So I'm going to say fine, and left, right. This is and expression 2. This is the result of the simplified that I just made, where the left child of that simplified is going to be the very same x. And the right child of that simplified is going to be true. Right? Then I ask myself, why? What is that going to be? How do you simplify y? Well, you don't, right? You cannot simplify y further. So you return that same y here. Then wait, sorry. Wait, I got carried away just a bit in my explanation. Yeah, I got carried away just a bit in my explanation. Okay, backtrack to the point where we called simplify on or calls simplify on and called simplify on x and true. We called simplify on x, we called simplify on true. We created a new and expression of those two lefts and rights. So we create a new expressions and expression of those lefts and rights. So it's going to call left is the same x, right is the same true. Then we're going to say that new thing that we just did. Yes, I was right. That new object dot accept the visitor simplified. And so that's going to return the simplified version of that if it exists. And in this case, and x true, well, that's just x, isn't it? Right? Because x and true, anything and true is just that thing. So this dot simplify is going to return an pointer to x. So you understand what's happening. Like in traverse of simplify, you always create a new object, and then after you create that new object, you return the answer of that object. So right now we're looking at or with a return of x. Then we call simplify on y. And simplify on y returns, well, y, because we can't simplify that further. So returns y. Then we create a new object, or, with x, y. So create a new object or of x, y. Then we say, okay, now this object accepts the simplify class, which means it has an accept method that's going to take in the visitor v, and it's going to say visitor.visit this. So the simplifier will visit this or expression that's just been created and simplify it and return a simplified version of x, y, or, but there's nothing you can simplify further, so it's going to return this, which means it's going to return this object that was just created, the x or y, and that final simplified object that was just created from the or x or y returned by the simplifier class is assigned to simplified, which means that simplified is going to point to this or object. And so, did we do everything right? Well, we ask ourselves, we've got 2, 4, 5, 7, 9, 12, 15, 16, 17, 18, 19, 20, 21, 22. So we've got exactly the heap size that was declared to us. And that's great now. And if we look at the original, well, we've got var, and so we've got how many x's created? Well, just one. How many y's? Just one. How many ands? 2. How many ors? 2. So we've got 2 ors, 2 ands, 1 x, 1 y. We've got 2 ors, 2 ands, 1 x, 1 y. A simplified visitor class. So we matched the solution perfectly. Okay. Then he asks us, what happens when you reach C4? Not the explosive C4, but like PC C4, right? What happens when you reach C4? Well, what happens when I reach here? Well, so there's obviously a new line that I need to write, and that's this line. Well, what happened there? Well, first of all, I need new objects, right? This line is just saying, oh, okay, or create or xy. Like, this type of question is just, this follow-up just says, oh, what if I now need to declare a new object? Now, this is where the garbage collection method matters, right? Up until this point, you could have said this is, sweep and track. You could have said this is hybrid. You could have said this is generational collection. You could have said this is ping pong. You could have said this is anything. It would not have mattered because I did not need to run my garbage collection at any point in time till here. But once I reach this part, the garbage collection methodology matters because the way that I proceed is going to depend on the garbage collection, right? So I need to declare a new object, but I have no space. So I need to do a mark and sweep, which means I need to look here and ask myself, what do I point to? So I look here and I say, okay, so this has a pointer. This has a pointer. This has a pointer. Simplified points to this OR expression, this OR2. This OR2 is pointing to my var expression and pointing to my y. And that's really it. No one's pointing to this AND expression except this guy, but no one's really pointing to this guy either. And no one's pointing to my simplified visitor, and no one is pointing to my AND expression here. Right? No one's pointing to these guys. So the only thing that I keep is going to be my var expression x, my var expression y, my OR expression 2, which has pointers to left and right, and that left and right, that left points to x, and that right points to y, and yeah, that's about it really, right? Like I don't see any other anything else that needs to be created. So now heap size is 22. I've used 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So now I have 10 left. And now I need to declare a new var expression x. I do a var expression x and a var expression y and an OR expression with left and right pointing to that newly created x and that newly created y. My simplified, as we promised, points to this OR, and my expected points to this OR x and y. And yeah, that's about it really. I mean, do we need anything else? No, did we do this correctly? Let's see. So we've got how many x's? Well, we've got 2 x's, 2 y's, 2 ORs. 2 x's, 2 y's, 2 ORs. Anything else? Nope. Nothing. So we've done this correctly, and in doing so you have demonstrated your ability to program correctly mark and sweep garbage collection. this will definitely be useful in the future.